So on this one, brings in a couple of skills. The first one deals with the circle itself. Of course, we're finding how many times does this wheel have to turn? How many revolutions of this wheel to go 3 miles? So first thing we need to do is figure out how far it is around the wheel. In other words, we're finding a circumference of a circle. Circumference, what is our formula for circumference? Pi times the diameter. So for this one, pi is 3.14 is what we normally use, times 27, which is going to give us 84.78. And that is inches because the 27 was in inches. Next, we have the 3 miles. We need to figure out how many inches are in 3 miles. Okay, well, let's step through it. 3 miles over 1. We're going to put 1 mile on bottom, 5,280 feet on top. So the miles are now gone, but we're in feet. 5,280, it's in the book. Okay. But yeah, 5,280 is one that wouldn't hurt to have memorized. I'm not going to require it. You'll always be able to look it up. And then 1 foot is 12 inches. So yes, 3 times 5,280 times 12 is, what'd you say? 190, sorry. 190,080 inches. So 190,080 inches. That's a different number. So now we have to go that far, this many inches at a time. So how many times does that wheel have to turn? 190,080 inches divided by 84.78, which gives us 2,242.04, we'll call it. That is revolutions. So if you said 2,242, that's probably close enough. Sure. There you go. So now remember, that's talking about the circumference, the distance around the circle, or the perimeter of the circle. What if we went the other direction and asked, what's the area of that circle? If it's a rectangle, so yes, area is pi times radius squared. So 3.14 times 13.5 squared. Half the diameter to get the radius. So 13.5 squared is 182.25 times 3.14. 572.27. And that was in inches, so that is now inches squared because it's an area. Look familiar? Okay. So last class we had basically 4 shapes that we worked with. And all of them were based off of the base shape of a rectangle. Because technically, area is really only defined for a rectangle. Everything else is derived from the rectangle. So if I have a rectangle that is 18 inches by 7 inches, how do I find its area? 18 inches times 7 inches equals 126 inches squared. Very good. So for a rectangle, it is just length times width. For a triangle, how would I find the area of this triangle? Base times height divided by 2. We're thinking of because it's half of the related rectangle. Here, what's the base and what's the height? We don't know. Okay? Depends on where the right angles are. If there's a right angle, right? If there were a right angle in this triangle, where would it be?
I would think 16 and 30.
Right there, and I'm going to put a question mark there because we don't know. Why would we say there? Because they look kind of like it. They're the two smallest sides. Yes, and as Natalie was saying, the two smallest sides are the only ones that can be the legs, because the hypotenuse has to be the longest one, if it really is a hypotenuse, if it's a right triangle. So let's check. How would we check to see if this is a right triangle? You got 16 squared plus 30 squared. Does that equal 34 squared? So 16 squared is 256. 30 squared is 900. That adds up to 1,156. 34 squared is 1,156. They do equal. So yes, that is a right angle, and the area can be found using 30 inches by 16 inches. Don't forget to divide it by 2. Gives you 240 square inches. What do you think? Look familiar? Okay, now I'm going to throw this one out just to see what you remember. Try this one. I'm going to give you a second in your notes to try that. Okay, so this, what type of a shape is this, by the way? It's a trapezoid. And the area of a trapezoid is perfect. The average of the bases, so big B plus little b divided by 2, times the height. So for this one, that's going to be 34 plus 16 divided by 2 times 22, which is going to be what, 550 inches squared? Remember, when you do this, 34 plus 16 is 50. Hit equals before you hit divided by 2. It'll go much easier that way. Now the circles we've already reviewed. So I want to take a little bit of time to go over the homework. There are two questions that always come up, and you guys have already brought up both of them. One is, it's number 14 in the homework. Usually it has the barn. Now each of you will have different dimensions. The dimensions it's giving me on the example I just pulled up in front of me here is really ugly, but why not?
Which one? I probably covered them all.
You probably covered every permutation of this problem.
And I'm really good at drawing barns now.
Good. Well, this one has a really high peak, apparently. 60 feet, 52 feet. This is 100 feet long. Now, the thing that confuses most people is it doesn't tell us how wide the barn is. But it does tell us that the peak length here is 68 feet for this example. How can I possibly find the width of the barn just with that slope length? This is the version you had? Cool. Well, if this height is 60 and that is 68, I can find that piece. Because if I call that A B and C, A squared plus 60 squared equals 68 squared. So A squared plus 3600 equals
4,624.
there we go. We will subtract the 3600. A squared equals 1024. And we square root that to get that A is 32. So A is 32 feet. So if that's 32 feet here, that means this is 64 feet because there's one there and one there. So now to find the area of the barn, called the vertical sides. It was often called the lateral area of the barn. Well, this is 100 by 52, right? Otherwise known as 5,200 square feet. There's another 5,200 square feet. Where's that coming from? The back side, you got it. Or the left side, if you want to call it that. Then the front here is 64 by 52, which is 3328, yep. And there's another one of those. Front side and then the other end. And then we also have a triangle here that is 64 by 60. Divided by 2 because it is a triangle. That's what, 1920? And of course another 1920 on the other end. So what do we get there? Oops, not 56, it's 96. $20,896 square feet. Does that sound right? Off of the picture up here. So this is 100 by 52 is this side here. The 64 by 52 is this rectangle. And then the 64 by 60 is this triangle. The total, 20,896. That was this triangle here. We got this piece here was 32, so then you doubled that to get 64. That would, the area would be in feet squared, yes. The second problem that is usually comes up on the homework is the airplane wing, which I believe was the last problem, isn't it?
Yes.
The airplane wing reduces down to this. Yeah, it sometimes does change the order depending on. So here's our airplane wing. Now I put this little gray, the rest of the whole thing doesn't matter, I was just the triangles. I put that little gray line across the bottom because that's actually significant in figuring this out. So what we're given is from here to here is 7 yards. And from here to here is 16 yards. Again, your numbers are most likely different. 13 yards here and 13 yards here. So in other words, 26 across the whole bottom. One of our strategies for finding areas, we can find different areas and add them together, or we can find areas and subtract them. This triangle right here is 26 yards by 23, and divided by 2 because it is a triangle. which is going to give us what? 299 yards squared. Does that sound right? Perfect. Next, we have this triangle. It's cut out because we don't have that whole brown triangle. We just have this up here. So we got to cut out that purple triangle on bottom, which is 26 yards by 7 yards high, divided by 2, or 91 yards squared, correct? So we subtract, that gives us 208 yards squared. Now then it gives us a price per square yard. The price on the example I'm looking at is $70 per square yard, so it's 208 times 70. What, 14,560? Questions on that one? Okay. That's a great example to start with, because that's what I want to build off from here, is those composite figures that require more than one shape. You know, there we had 2 triangles, but we might have something as simple as this. Excuse me. When working on a problem like this, we have 2 options. Now, first thing you'll notice, there's a couple dimensions missing here. We don't know this dimension or this dimension. What's that horizontal dimension have to be up here? 15, good. Because there's 22 across here, it has to be 22 across the top, right? We have 7, so 7 and 15 make 22. Now, is there anybody that's not sure where that 15 came from? Because that's the first step. If you can't find that, you're out of luck. You can't get these to work at all.
So you just minus 5 from the top.
Yes, 22 is the total length, because that's the total length, and you subtract 7 from it, because you already got a 7-foot piece. Because you know that from here to here has to be the same length, whether you're going across the bottom or the top of the piece. So then, what is this side have to be? 14, good, because this is 18. We know this is 4, so it takes 14 more to get up to 18. So now that we've found those missing sides, we have 2 options. Option 1 is to cut it into smaller pieces. So to do that, I could cut it in different ways. I might cut it across here, or I might cut it down here, either way. I'm going to cut it horizontally like that first line. So now what I have is I have piece A here, which is 4 inches by 7 inches, which is 28 inches squared. And I have piece B here, which is 14 by 22, which is what, 308 inches squared? So we add those together to get 336 square inches is my total area. Option 2. Severely abbreviated here, but to make take a larger shape and then remove the missing pieces. So here that would look like this. I would take this big rectangle, which is 18 by 22, which is what, 396 inches squared, and then remove the missing piece here, which is this rectangle here that's missing. That's 4 by 15. which is going to be 60 inches squared. I subtract that, I get 336 inches squared. Now you see I get the same answer. Now in this example, it's about the same amount of work either way. But there will be some examples that have to be done one way or another, especially when you involve circles. Why? I love that. If I asked you to find the area of this, it would not work well to find a bigger piece and subtract off. This one, the best way to do it would be to cut it into two pieces and find each area. So area A here is a rectangle. I find its area by doing what? Length times width. 12 inches by 15 inches, which is 180 inches squared. Area B up here is a half circle. Its area is going to be the, first of all, I need what? I need to know for the area of a circle the radius. What's the radius going to be? 6 inches. Because if this is a rectangle here for piece A, this also has to be 12 inches, which would be the diameter. Half of that would be 6. So that area is pi, or 3.14, times 6 squared. But I'm going to divide by 2. Where does that dividing by 2 come from? It's only half the circle. Very good. So what does that become? What, 66? What is it? 56.52. Thank you. That is correct. 56.52 inches squared. And now we add those together to get 236, not 26. The little hamster is stumbling tonight, so you have to double check my calculations. 236.52 inches squared. That is my overall area. So there's one where the best option, really the most reasonable option, is to cut it into smaller pieces and add them together. But we can run into one like this. Where Arkansas? I never would have found that shape in there, but I guess maybe. Finding something like this. Well, here's one where I can't cut this into smaller pieces and add them up. It just would not work well at all. So I'm going to make it larger, like this. So the area of the larger piece I know is 16 inches. That's this whole height here. Do I know this whole dimension? Not 20. 20 ends right here. What's this piece have to be? I'll ask you an easier question. What's that piece have to be? 4. 16 minus 12, right? If this is a quarter circle, if this is 4 inches, this got to be 4 inches. The radius of a circle is the same no matter what direction you're going. So the overall length across here then has to be 24 inches. So 16 times 24 is what, 384? Or 3840? Help me out. 384, there we go. Inches squared. So then we've got to subtract off this triangle. How big is that triangle? this has to be how much? 16 minus 11 makes that 5. Good. What's this have to be? You got it. 24 minus 12 makes this 12. Now I'm going to pause before I find the area of that triangle. Any questions on where the 5 and the 12 came from? That is a common struggle, finding those missing dimensions. And if you can't do that, then there's no way you can get the area if you can't find the dimensions. Okay, great. You guys are all ahead of the curve if you're finding those dimensions okay. So then that is 5 inches by 12 inches divided by 2 because it is a triangle. Gives us 30 inches squared. We subtract that out, we're down to 354 square inches. But then we also have this quarter circle here. That quarter circle is going to be pi times 4 squared divided by 4. Right? Pi times radius squared, and the radius is 4. But it's only a quarter circle, so we divide it by 4, which gives us 12.56. We subtract, this is 341.44 inches squared. That is our area. What do you think? This is fantastic. Good. I'm sensing a little sarcasm there. Just a touch.
Just a little?
What if I were to ask you to find the perimeter of this? Perimeter is the distance around. So I've got 11, 20, 12, and 12, right? So I'm going to add up 11 plus 20 plus 12 plus 12. Now I have to find...
Wait a minute, you've got that, and then you still have circle stuff.
I've got to get the half circle yet. I haven't done anything with the half circle yet. I'm going to find this piece here from the triangle first. How do I find that piece? You got it. A squared plus B squared equals C squared. That is side C. So 12 squared plus 5 squared equals C squared. 12 squared is 144. 5 squared is 25. Adds up to be 169. The square root to get 13 is C. So C is 13, so we're going to add 13 to the end of that. And then we still have our quarter circle here. That quarter circle is pi times diameter, which is 8, right? Divided by 4 because it's only a quarter circle. Where'd the 8 come from? Double the 4, yeah. 4-inch radius, it's 8-inch diameter. So it's 6.28. So we add those all up, and we have 74.28 inches is the perimeter. Any questions? Didn't follow any of it? Okay, perimeter is just adding up the sides around the outside, right? So the 11 here, the 20 there, the 12 here, and the 12 here are already given, right? So we added those 4 together first. Then to that we have to add this piece here. And that's where we use the right triangle and the 5 and the 12 to do a squared plus b squared equals c squared. So 12 squared. Not for this again. The 12 just goes from here to here, but the perimeter goes across the slant here. So we got to find that slant length. If we were going to wrap a string around the outside edges of this, we'd have to know this distance. Because the string doesn't go out here. It goes across the slant. So that's where we did a squared plus b squared equals c squared. We got 13 for that. That's where this one came from. And then we still had this piece here, the quarter circle. If you think of that as being a full circle, it would have a diameter of 8, because it has a radius of 4, double the 4. So its circumference would have been pi times 8. Then since it's only a quarter circle, we divide it by 4. So that is the last piece of our perimeters at 6.28. It does help to have different colors, yes. I've had a lot of students do that in the past, bring in different colored highlighters or different colored pens. It does help a little bit. That's a foot symbol. What I want you to find here is the area of this track type shape. So the part that I'm coloring in with highlighter here. Find that area. I will pause the recording for you for a while. Give you a little time to work on it. So this one looks terrible, but it's not nearly as bad as it looks. First, we can cut it like this. And we have a rectangle here. How long is this rectangle? It's 60 feet. How do I get that? Well, if the radius is 30, this is 30 feet here, and it would have to be 30 feet here. So 120, subtract 30, and subtract 30 again is 60. How wide is this? 10 feet. Again, if it's 30 all the way out and 20 to here, the difference is 10. So this rectangle up here that I labeled rectangle number 1 is 60 feet by 10 feet, or 600 feet squared. Guess what? Rectangle number 2 down here is the same. So all we have left are these curves, the turns. If I take them and I pull them out and I put them together, I have a full circle, a big full circle with a little full circle cut out of the middle. So by cutting it apart and putting them back together like this, I have a big circle that has a radius of 30 feet. So that area of the big circle is 3.14 times 30 squared, otherwise known as, what's that? Yeah, pi times radius squared, yep. What's that? 2,826, yes. Yeah, that is pi times radius squared. It's 2,826. And that is feet squared. Now that's not the area of the thing though, because we got to subtract out the little circle in here that is 20 feet in radius. So the area of the small circle is 3.14 times 20 squared, or 1,256 square feet. If we subtract that, we're going to get 1,570 square feet, correct? You'll take my word for it again? So the arches are 1,570 square feet. plus the 600, and the 600 is 2,770 square feet of area. Anybody have that? Any questions on how I got it? The 10 feet here? Okay. Because if it's 20 feet, or 20 feet to here, right? This is the 20-foot radius. Then it's 30 feet all the way out from this end. So the difference between 20 and 30 is just 10. Obviously not drawn to scale, which makes it a little bit confusing. So that's 10 feet. So this is 60 by 10. So we got two of those. Did you follow any of the stuff on the circle here? Okay. Any other questions? Now I'm going to ask you a question that's not nearly as tough as it sounds again. Find the outside perimeter of that. I'm going to pause it. Let's take a peek. So the first piece we have, if we're just going around the outside of this now, we have 60 feet right here, correct? We also have another 60 feet up here. So I'm finding the perimeter. I have 60 feet plus 60 feet. And then I have the two arcs, which is just the perimeter of that one big circle. So the perimeter of that big circle, circumference is pi 3.14 times 60. Where'd 60 come from? It's a radius of 30. It's a diameter of 60. So was that 19 point? What's that? 188.4. Okay. Feet. So that adds up to 308.4 feet is the outside perimeter. What do you think? Well, the good news is that's the end of the first hour of class. It's time for our break. Let's go on break. We'll come back and start lecturing again right at 4:30.